This is question 67 on chemistry from the 2011 IMAT. So we're told that one particular group in the periodic table contains the elements boron, aluminium, gallium, indium and thallium in descending order. And so which of these are correct concerning these elements? So firstly, indium forms the oxide In2O3. Then boron is the least reactive element in the group. And gallium forms the sulfate GaSO4. So firstly, it would help massively if we knew which group in the periodic table this was, and if we don't know it already, we can work it out by knowing that aluminium always forms the Al3+ ion, or that boron forms molecules such as Bf3 with this planar arrangement. And from these, what do we see? That they must have 3 outer shell electrons. So which group is it? It is indeed group 13. So they go down here like so. So let's look at these statements. Does indium form the oxide In2O3? Well, what ion would indium form? If aluminium forms 3+, and it's in the same group, then there's more than a good chance that indium will also form 3+. And what's the charge on oxide? We know this is -2. So does this make sense? If we have 2 indiums, that makes +6. If we have 3 oxides, that makes -6. So this formula looks correct. So next, we're told that boron is the least reactive element in the group. Would this make sense? Well, what do we know about reactivity trends across the periodic table? We know that for the metals, reactivity generally increases as we go down the group. I'm sure we've all seen the experiment of lithium versus sodium versus potassium with water. And is this a metallic group? Well, we know that aluminium is a metal, and so anything below aluminium must also be a metal. So it's safe to assume that this group will follow the metallic trend in reactivity. And what would that mean? That boron, being at the top, would indeed be the least reactive element. And finally, would gallium form this particular sulfate? Well, we know aluminium forms 3+, indium forms 3+, so chances are gallium is also going to form 3+. And what's the charge on the sulfate ion? We should know that this is -2. So this wouldn't be a 1-to-1 ratio, it would have the same formula as this, the 2-to-3. So we can say that this would be wrong. So that's our final answer, that 1 and 2 are correct, but 3 is wrong, which corresponds on the question paper to answer B.